Hey y'all, in this video we're going to take a look at equations that have no solution or infinitely many solutions. Up until this point, all of our equations have had a single solution, and so we're going to take a look at what happens when they don't. So our I can statement is I can determine the number of solutions to an equation. Our essential question for you to fill in on your notes is, will a one variable equation always have only one solution? The first example we're going to take a look at, again, I have written this out for you in your notes, but if it helps you to draw a picture, please do so. We're looking at a rectangle and a triangle, and we're wondering what values of x will the rectangle and the triangle have the same perimeter, so when they are equal. We know that the perimeter for a rectangle is going to be 2 of the shorter side plus 2 of the longer side. So you see that in your notes as 2 times x plus 2 times 2x plus 3. The triangle's perimeter we can see has all the same length, so it's 3 of 2x plus 2. So we can do 3 times 2x plus 2. We're going to be setting those equal to each other to find out when they are the same. So here we have our problems, and we're going to write the equation to represent them, then use inverse operations and properties of equality to solve. So again, here are those two equations that I have in your notes that you are going to start solving. We are going to first start by distributing and combining like terms. When we distribute, we'll just get 2x, and then here we'll get 4x and 6. So 2x plus 4x is how we get this 6x, and 2 times 3 is how we get the 6. On the right side, distributing the 3 times 2 is 6x, and 3 times 2 is 6. So I've just distributed and combined like terms to get to my simplified version of this equation. Now we have 6x plus 6 on one side and 6x plus 6 on the other. Take a moment to think about what values of x could I plug in for these to stay equal. Well, as I solve, I'm going to subtract out the variable part from one side. In this case, they're the same, so I'm just going to subtract 6x from both sides, and I'm left with 6 equals 6. This is a true statement, like we mentioned before. Because 6 will always be equal to 6, it really doesn't matter what I put in for x. No matter what I put in for x, this equation is always going to be true. So no matter what value x is, the perimeters will always be the exact same. Doesn't matter what I put in for x, it's always the exact same. So this is an example of an equation with what we call infinitely many solutions. Let's look at an equation with one solution. I'm going to go through this quickly because we've been solving a lot of equations with one solution. Anna and Lee played soccer for the same number of hours in 1 week. That's how we know they're setting them equal. How many hours did Lee play on Sunday? Well, we can see that Lee is x hours, then 2.5, then 2x, then 4.5. We see that Anna played x number of hours every morning and 1.2 hours every afternoon. So we know that she has played every day x plus 1.2, and she did that for 4 days. So that is how we get 4 times x plus 1.2. And Lee doesn't have any repeating, so we just list his out as all 4 terms. We're wondering when these are equal. We'll distribute to get 4x plus 4.8. Then we'll combine like terms. On the right, x plus 2x is 3x. 2.5 plus 4.5 is 7.0, or just 7. So now we have a simplified version. We'll subtract the smaller coefficient. So 3 is smaller than 4, so we subtract 3x on both sides to get x plus 4.8 and 7, and then we subtract 4.8 from both sides so that we have just x equals 2.2. This is very much like solving your equations in Lesson 5. The equation has one solution because x equals 2.2. So Lee played soccer for 2.2 hours on Sunday. Our last example here is going to show what happens when we have no solution. So Jill makes 3 bracelets and Mika makes 2 bracelets. They both use the same number of string colors. How many colors could they use to make the same amount of money? So we're wondering for what number of string colors they can make the same amount. So Gil, we're going to write an equation, and we're going to use X as our string colors. So Gil is making 3 bracelets, and they're $5 plus 2 times whatever X is. So you can see in your notes that I have the expression 3 parenthesis 5 plus 2x. Then Mika is making 2 bracelets. Hers are $3 and 3 times whatever x is. So you can see in your notes I've already put that as 2 times 3 plus 3x. And we are wondering when these are the same, so we're wondering when they are equal. So here is the equation we have set up and are going to try and solve. The first thing we'll do is distribute. 3 times 2 is 6, 3 times 5 is 15. On the other side, 2 times 3 is 6, and 2 times 3 is 6. So we have 6x plus 15 equals 6x plus 6. Very much like the first example, we're going to subtract 6x from both sides, but now we'll be left with 15 equals 6. We know that 15 is not equal to 6. So, because this can never be true, there is no value of x that we could use that would end up working. So because we get this statement that is not true, there is no solution. There is nothing we could plug in for this to work. So we say the equation has no solution. So there is no way that they can use the same number of colored strings and make the same amount of money. You have 2 problems to try. One has you filling in and solving the equation. You're then going to write how many solutions it has. And same with the other one. Combine like terms, solve the equation, and write down if it has infinitely many, 1 solution, or no solution. Pause the video, try these problems, and press play to see the answer. With our problem here, we're going to combine like terms. 2x plus x is 3x, and 10 plus 5 is 15. Then we're going to subtract 3x from both sides, and we end up with 15 equals 15. So this tells us that the equation has infinitely many solutions. For the other equation, we are going to combine like terms. 0.1 plus 3.9 is 4, so we have 4x plus 8 equals 4x plus 3. We'll subtract 4x from both sides and get 8 equals 3. We know this is not true, so there is no solutions. The equation has no solutions. We'll finish up a reminder that how you can determine the number of solutions without solving. If an equation has 1 solution, it will have both sides of the equations will have different coefficients on the variable. So it'll be like 4x and 5x or something like that. So both sides of the equation will have different coefficients. You can tell there will be infinitely many solutions if, when you simplify, both sides of the equation have the same coefficient, and the same number being added or subtracted. When we go back and look at this example, we see here same coefficient on x, 3x, and they're both adding 15. So they're literally the exact same. That is how we know that there are infinitely many solutions. And we will know that there are no solutions because both sides of the equation will have the same coefficient, but a different number added or subtracted. Here we both have 4x, but we have 8 being added and 3 being added. So I know before solving it that this is going to be no solution. So, summing it up, basically what I just said, an equation has infinitely many solutions if you get a true statement. It has one solution if you get x equals that solution, and it has no solution if you get an untrue statement when you've solved. Your next steps are to submit your 3.7 notes and work on your 3.7 practice. Your practice is on Schoology, but in your notes packet is a page of scratch paper. Once you've completed your practice, you can continue on to your 3.7 mastery check and then continue on to the next lesson. Good luck, and I'll see you there.